Hello, Antonio's Fixeria. Uh-huh, uh-huh. So that's a 12-inch masonry with expansion bolt, screw plugs, and sort of fixings. No problem. About 15 minutes. Hi guys, the last two videos were about buying your first drill and then the tooling that you could use in it to make holes, use fastening and other equipment. Now today we're going to look at fixings to use to fasten into walls. This is an overview rather than a complete primer on every aspect of wall fixing. Each individual section that we'll be looking at today has a huge area behind it. If in doubt, I'd strongly recommend getting advice from your local hardware store for particular applications. Those guys generally have a wealth of knowledge and they're aware of all the flavours, shapes and sizes of fixings. YouTube and the internet are also super resources for researching and getting information as well. Now, before we get into the details of the different fixings, the guiding principle behind attaching into a wall is to use the fixing itself to either deform inside the hole or behind the surface that you're attaching to, or alternatively then to cut a thread form into it. In the case of wood, which is a soft material, it uses a combination of both deformation of the fixing and also a thread form being created by the screw itself. I've made a diagram there to help us navigate, and I've also timestamped the various sections. You can see them along the bottom of the screen here, so you can skip through to the particular section you're looking for. Now, we have four main sections. We have concrete, steel, wood, plasterboard or drywall, and then I've divided each of those four main sections into sort of a light and heavy duty fastening operation. Now, first up is concrete, and for light duty purposes for fastening into a concrete wall, we can use a selection or a variety of sizes of wall plug and screw. The principle behind a wall plug is that the plug sits snugly or securely in the hole that you've just drilled, and then as the screw is screwed in, it expands the plug and it creates a compressive force inside the hole. Now, the best place to start as regards organising and fastening into a wall is to start with the wall plugs themselves. My very strong recommendation would be to buy these by the box or the bag, where you'll have the information available to you on the box or bag or whatever. Now, if we look there, and this will give us a good example, here we have the size of the hole to drill. Here we have the depth of the hole and the depth of the wall plug itself, and then over here we have the range of screw sizes for which this wall plug is suitable. Sometimes you'll buy wall plugs by the strip, and if you note, sometimes the strips themselves will have the same information printed or embossed on the back of the strip of plugs as well, giving you the various sizings. Now, if all else fails, what we can do is we can actually measure the plug itself. So here's a plug. We'll turn on our calipers. We'll try and measure that so you can see it. And that gives us, just there at the top of the plug, 7.49. So that indicates then that it's an 8mm hole that needs to be drilled there. These are difficult enough to measure because they're quite soft, okay? But you'll get a good indication there of the size drill bit you need. A good guide or a good rule of thumb is that the longer the screw that you're using is, the harder it is to pull out of the hole. There's more length of compressive attachment, but then the wider the screw is, the more static load it can take in terms of weight. Now, when you're drilling your hole and you need to know the depth, there's two methods of doing that. Number one is the drill that you bought should come with a depth gauge, and it's just a little piece of plastic that you can set forward and back on the handle of the drill. Or the second option then is to put a piece of tape around the drill bit itself, and you'll see that there in the next video that I used that option. Now, I have my drill marked off to 45mm as per the instructions on the box of roll plugs. Now you'll note there that I moved the drill in and out of the hole to evacuate as much of the dust as possible. Next we put in our wall plug, and that should just squeeze in gently there. And now we'll insert our screw. And that is a screw in a wall plug with a concrete fitting. Now for heavier applications in concrete, we move then on to a different style of anchor. There's two broad areas. The first is sleeve or wedge or expansion bolt types. And I'll just demonstrate one of these to you now. The common design is there's a wedge down the bottom of the bolt. There's a sleeve or a collar here in the middle, right? And then as we bolt or advance our bolt, that wedge moves its way up into that sleeve, spreads the sleeve, and that comprises or it creates compressive force inside the hole. And I'll just try and point that now so you can see the spread sleeve there. They come in different styles, but the overriding principle remains the same. And again, we'll just tighten this one up again, and you might be able to see that the wedge bit at the bottom spreads the sleeve and again creates compressive force inside the hole. So that's that. Now I'll just demonstrate one of those being mounted into the wall. Now that we have the anchor bolt in the hole in the wall, what we'll use to tighten that in further or use as our fixing is the nut. And what we can do there is, if we were attaching something to the bolt, we can put that on behind the washer, put the washer on then, and then we'll use a spanner or a wrench, and as we turn that, that's pulling the shaft of the bolt out of that wedge, and the wedge is opening inside the hole now, and this will get harder and harder to turn as we pull that out, and that's what secures it in there. So that's a wedge bolt or an expansion bolt. Now, the second classification of heavier duty concrete fasteners are what are called screw anchors. I'll just show you one of these now. Effectively what these are bolts or big screws that get driven into concrete. These ones here are 10mm by 120mm, and what we do with these is we drill a 10mm hole, a suitable length, and then we can put these in either with a wrench or a spanner, or as the bolts get bigger and go into deeper holes, impact tooling becomes very handy then, especially if you have a lot of these to put in. Now again, right, and I'll keep emphasizing this, is buy these things by the box or the packet where you get the information with it. This tells us here the size of the hole to drill, which is 10mm, the various depths of the hole to drill then in different materials, and the wrench or the spanner then that we need to tighten it. Right, we have our hole made, and what we do then is we screw in our anchor, and we can do this two ways, either one by hand, which is going to be tough because it's a big anchor, or we can use an impact wrench or some type of impact tooling, so just mind your ears there. Now when it comes to fastening through steel, we have one heavy duty option and a number of lighter duty options then. We'll do the heavy duty option first and get that out of the way. The majority of the time what we'll be looking at is nuts and bolts. The downside to this is obviously that you need access to the rear of the member that you're fastening into to be able to put a hole through it, insert the bolt, and then put the nut on the end of the bolt and tighten it up with obviously a spanner or a wrench. Now there are heavy duty nail guns which will affix into steel, but they're not really a homeowner type of operation. They're quite expensive bits of gear. When it comes to the lighter duty side then, we have a number of options. We have steel fixings which come in a huge range. They can range from fixing light sheets into heavy steel, light sheets into wood, heavy sheets into wood, etc, etc. The instructions will be on the bag, and once again, buy them by the bag where you'll have the instructions. And just for information, or so you can see it there, these are specific ones which are roofing and cladding fixings to self-drill fix through metal roofing and cladding sheets direct to hot rolled steel from 5mm to 12 meters thickness. And the way they operate is that you use a little hex driver. This is an 8mm, which would be about 3/16 I think, driver that clamps into the drill in the hex side, or an impact driver. The fixing is magnetically held into it there, and then it's just drilled in, and I'll just give you a demonstration of that there outside. Now what we have here is a piece of 9mm steel angle just clamped to the bench, and what we want to do is have a look now and see how the self-tapping screws work. So that worked well. Now the other light duty option for fixing into steel is with rivets. This is a rivet here now, and I'll demonstrate how they operate again out in the shed in a sort of a real world scenario. Now just to demonstrate how rivets work, I have a piece of steel here with a 5mm hole drilled in it, and I have here a 5mm rivet. And the way these work is that the rivet goes into the hole, and then a tool, which is a rivet tool or a rivet gun, is used to pull this pin back through the rivet body itself, and there's a rounded bit in the end there which keeps pulling that back, and it deforms it or squashes it up until the point where it clamps against the front head, and at a particular point then the pin breaks out. I'll just demonstrate you now just for and now if we look at the rear of this little plate, we'll see that that body of the rivet has been squashed up, and that the little rounded bit has gone as far as it has gone through, and you can pin together, you know, small sheets of steel, or you know, from steel sheets into framework, or other uses like that. Okay. Now when it comes to fixing into wood, the principles behind it are a deformation of the material, which effectively means that we just make a hole by using a screw or a nail. And when we use screws, we also create a thread form whereby the spirals on the screw eat into the wood and create sort of further adhesive power or bonding power. Now nails just utilize the deformation of the material, and I've just a few examples laid out here, and they go from the tiniest little tacks, which is about, I don't know, 20mm or 3/4 of an inch long. They're little tacks for frames or whatever, through to much larger 6. This is a 6-inch nail, and they go up as far as 9-inch nails as well. Generally speaking though, the nails you'll be using, we'll say for general maintenance around the house, will be either bright round nails like these in a variety of sizes, or alternatively bright ovals, which are like this. Now the oval nails they're like a little rectangular or an oval shape, and the logic of this shape is that as they go in to the wood, if they're along the grain of the wood, they don't stress the material as much. So if you're using stuff close to an edge, or the material is light or quite small, oval nails will give you a slight advantage over rounds when it comes to avoiding splitting the material. Now when it comes to wood screws, there are possibly thousands of different varieties. Here's just a few I have in the workshop. The all-purpose or general purpose screws will be like these fellas. And I'll just show you one of those to show you what they're like. They'd be sort of a thicker screw, and they obviously come in a variety of widths, dimensions, lengths, etc, etc. When we move into the other types of screws that you can use, we have exterior wood screws here, which are treated, and they're guaranteed corrosion resistance for however long that lasts. These here are decking screws, and just one point to note with the decking screw is that the drive head on those requires a Torx driver, so keep an eye out for that. One last thing to just mention when it comes to screws, you'll come across drywall screws quite a lot, or plasterboard screws, and generally they're quite long, but what you'll find is they're particularly thin and have a tendency to break. They are designed just for plasterboard and not for any structural or weight bearing loads. Now when it comes into the larger wood fixings that we need, we have a choice available to us of lag bolts, they're called. Now basically what they are is just huge wood screws with a hex head that can be driven with a socket, or alternatively with impact tooling as well. Now plasterboard, which can also be called drywall or sheetrock, gyprock, and a few other names, is the most difficult substance to attach to. It's very brittle. It's made up of sort of a powdered gypsum pressed into sheets held together with effectively cardboard. So it doesn't have huge structural integrity, and the principle behind plasterboard walls is that a framework of upright wooden supports is built generally with 4-inch by 2-inch members. These can vary depending on the spec used by the carpenter and also the preparation of the wood, and sometimes you'll see bridging across between the upright sections underneath windows and along various bits of the length. The uprights are spaced 16 inches between the centres, or 400mm, and that leaves about a 14-inch or 350mm gap between them. Plasterboard then is, or drywall, is screwed onto these uprights, and then that's finished generally with some type of plaster or tape to fill in the joints and hide the joints. Now, as I said, plasterboard is particularly brittle material, and it doesn't have any large structural strength. So when we're fixing into this, we must spread the load over it as wide as possible. All fixings then for plasterboard operate in the same principle. We get as large a load spreading fixing into a hole as we can, and then that'll expand behind the board and spread the load. Now I'm going to demonstrate the principle, or the first one anyway, of just a normal wall plug. And we'll just zoom in slightly there now, so that you can see both sides of the sheet. Okay, mind your ears. Okay, now this particular fitting is an 8mm fitting, so we'll stick that into the hole and press it in so that it's flush. You'll see that sticking out on the rear there. And what we'll now do now is use our impact driver to put the screw into it. And as the screw goes in, you'll see the rear of it here expand out. Now, I'll stick up pictures to go through the other options. Some of them are better than others. Once again, I'd emphasize the importance of buying something in a packet so you can see the load bearing capabilities of it. I'd also suggest that you over-engineer, over-spec your fixing to cater for any inherent weakness either in the installation that you're doing or the drywall or plasterboard itself. Basically just make sure that your new flat screen TV doesn't end up on the floor. Now, keep in mind as well, I'll just zoom out there slightly. Keep in mind as well that shelving brackets exert what's called a cantilever force. So as the weight is sitting on the top of the shelf here, it's pushing down this way, and it's actually creating a leverage or a lever point off the bottom fixing. So just take that into account when you're putting in especially shelving brackets. Okay, now first up there are the specialist plasterboard plugs. These are better obviously than your standard wall plugs, which are generally designed for concrete or you know, a hard fixing like that. Now these come in a large range of designs, but they all share the same idea of the screw as it advances into the fixing, deforming or pulling the fixing into a wider shape behind the hole. Now, next up is a large screw fixing, which just screws into the plasterboard as a large anchor, and then a smaller screw screws into that screw fixing. Toggle fixings, they act effectively like an umbrella, which opens up behind the hole. Depending on the size of the toggle, these can provide significant anchoring forces, and I'll just demonstrate how one of those works now. Now, the way these work is that the toggle folds up like that, goes into the hole, and then when it's through the hole, it pops out again like a little umbrella and provides clamping force then to the back of the hole. And I'll just demonstrate that into the piece of board now. And what we can do then is pull this tight. And we just tighten that in then with our screw. And as you can see, that tightens in nicely there. Now, when it comes to very heavy duty fixings, we have a number of choices. Again, the principle remains the same, that these fit through the hole into an expanded shape behind the wall. A small downside to these fixings is that they require quite a large hole through the board, so keep in mind that it'll be a bigger patch up if you take the item down and need to make good. Now, this is a picture of what are called grippet fittings, and I have a number of pictures there. As you can see from the packet there, they have an outline specification of 113 kilograms, which is nearly 250 pounds, and that's significant holding power. The way they work is that they go into the hole, and then there's two little wings on the back which open out and provide the clamping force of the back of the hole. Another example I came across recently are called G-fix fittings. I haven't tried these, but they look good. I'm going to stick a link in the description down below underneath of a YouTube channel called The Ultimate Handyman, who load tested these anchors, and that's well worth a watch. Now, if after going through all of these fixings we still need more strength, then we must look at attaching into that wooden framework behind the plasterboard. To do this, we'll need to locate the studs using a stud finder. Now, there are many makes of these, ranging from the most basic magnetic ones, which locate the screws used to hold the sheets into the framework, and there's much more advanced ones as well. Now, again, I've linked to another YouTube channel called Project Farm, who put all these different types of stud finders through testing. Well worth the watch if you're looking to get one of those. Now, my last point on plasterboard is that if things go badly astray, don't panic. It is possible to cut out a square of plasterboard and then to replace it and make good again without too much difficulty. So if things go really south, don't panic. Okay, now that's about everything, so thanks for watching.